So I will talk a bit about why do we even need no-code interfaces for quantum computing, and later I will talk a bit about how. So maybe not like just about certain things from the design process that I think might be valuable also during a hackathon, or in maybe more in general, not a very general design process that would definitely take too much time, but just a few things. I'll show you two interfaces, no-code interfaces that I've designed that are available online. So first one is available at lab.quantumflytrap.com, and this is an interactive optical table, so an interactive no-code optical lab that we've created. It's a project I co-founded with physicist Piotr Migdał, and we worked with amazing software engineer Paweł Gorabasz and a few other contributors on different stages of the project. And this is an educational project. It's a no-code interface, but it's mostly educational. And a second project I will talk about, and I'll show you, is Pulsar Studio that we've developed for Pascal. I was leading the design and development of Pulsar Studio, and it's a algorithm development platform for neutral atom quantum computing. And it's very hardware-based, and this was also the idea of this project. I don't know if you know much about Pascal and their technology, but on this interface, you can also see the main elements and the most important elements of their technology. For example, registers of atoms, so those little dots here. I can actually show the live version, so it's very interactive, and channels with light pulses, sequences of pulses, of light pulses, measurement. So this will be the second interface I'll be talking about. And just to start, what is a user interface? I'm sure it's something that everyone knows, but to quote Wikipedia, a user interface is the space where interactions between humans and machines occur. So this is a tool, a means of interactions, a way we interact with a particular technology. And there are many different kinds of interfaces, as I'm sure everyone knows. There are text-based interfaces, code, visual interfaces, physical interfaces, audio interfaces. We can design the interfaces in many, many different ways. We can make the experience efficient, frustrating, empowering. And I think all of this is very, very important, because the way we choose, the kind of interface we choose to provide for a technology and the way we design it is basically deciding who can participate in a given technology. And I think this is a very, very powerful position. And I really think this should be treated as something very important. And especially when we're talking about quantum computing, so a technology that could potentially change the world or potentially impact everyone's lives, I think the decision of who can participate in this technology in some way, even just to understand it, even just for public debate, I think this is a very, very important decision. And from the perspective of interfaces, the way I see it, and I think is very important in general if we talk about any kind of technology, but for sure for quantum technologies, is building very many different ways of accessing the technology. So different types of interfaces. And today I'm talking about no-code interfaces, and I see those interfaces as one of those ways. So it's not a universal interface that I think everyone will use, but for specific use cases and for specific users, I think this interface can be more valuable than some other interfaces. And so what we currently have, most of the interfaces that we have for quantum technologies currently are either just code interfaces, usually Python code, or textbooks, scientific articles. Maybe it's not exactly an interface in this traditional way of thinking about interfaces, but in this case, I think it's good to think about it as an interface as well, as a way to access the technology. And these are great. And, there are a lot of very, very smart people making those amazing tools. But still, I think there are certain situations when these are just not enough. And I think we need to think about different ways of accessing the technology. I mentioned the public debate. So for sure, for this might feel still a bit early, but I do think it's important. But except for the more general audience that needs to learn about this technology, it's for sure important at certain business situations, for sure for education, but also for researchers. I think there are certain specific situations when some things can be done in a more efficient way with, for example, a no-code interface. And this was the thinking behind the idea of building Pulsar Studio. So Pulsar Studio is not supposed to be this is not supposed to be an interface that is used instead of, for example, Pulsar, a Python interface for Pascal's technology. It's not instead of scientific articles, but we produced another different way of accessing their technology. So now, instead of those two main ways of accessing Pascal's technology, we built a third way. And I think in general, we can say that in certain use cases, for certain users, no-code interfaces can be more efficient, more intuitive, or more accessible. And I'll show you a few examples of how I think it works. The first example is actually a very different interface. It's something from when I was so to talk about this more, the general public, so people that don't know much about quantum technologies, I do think it's important, might be important for a number of reasons for them to have some ways to interact with this technology anyhow. But this example is me being a general public a few years ago when I had absolutely no knowledge about quantum computing or quantum physics, and I was invited for a few months to CQT, Center for Quantum Technologies in Singapore. I was invited as a visiting designer to work on an educational project there, and this was my first time ever I was working with this technology. And there was a moment we had a lab tour, I think, and there was someone working, I don't even know what was exactly this interface, but it was something with atoms, ions in this case. And I recorded it. It was some kind of very low level interface for hardware. And there was the screen where the scientists could observe if there is an atom there, if there is an ion. This white group of white pixels is an ion. And for me, this was the moment I was like, okay, I know that atoms are here. I understand this on some very abstract level, but then seeing this moving here thing, and obviously, it's not a picture of an atom, right? It's just some kind of representation, a visual representation. This could be just numbers, for example. But seeing this in a visual form was extremely powerful. It's like, wow, it's real. Like atoms are really here. Yeah. So this is my first example for the from my example of being a general public and seeing something, having an access to this technology. This is again Pulsar Studio, and it's some GIF I made for the beginning of the year. So I arranged the atoms and the light pulses. This is obviously not very useful as an actual algorithm, but the thing is that we try to design the interface in a way that it's very easy to use. So I'm not an algorithm designer, so I obviously don't really know how to design algorithms there, but it's very easy for me to still use it. And there was someone, I think last week, who wrote a review because it was just published recently. And there was someone who wrote a review, and he wrote that Pascal's Pulsar Studio is fun for the whole family. And I actually really like this, the way he described it. It's also a very positive review, by the way, and this person is obviously a professional. But I really liked the sentence, because I thought, like, I mean, first of all, I don't think there are many things in quantum technologies that were described as a fun for the whole family. So I took it as a big compliment. But I think what he meant was probably exactly this thing. So it's useful for him as a professional, but it's also something that you can sit with your child and show them in an interactive way. Yes, we arrange atoms here. You can move it very easily. And there are light pulses. So I imagine this is what they meant. So this is from this, this more like general public view. And another, I think, very important use case for no-code interfaces would be for education. And our lab is being used, for example, at some introductory course to quantum information at Oxford. They're using just a regular textbook, but then they're using our lab to show certain experiments in a more interactive way. And I think it's such a no-brainer. I mean, obviously this is a very nice thing and it's very much, I guess, a bit more interesting for some of the students than only the textbook, right? And in this particular course, working with code wouldn't really be a solution, because not everyone there would even know how to work with code. But we were also approached it was an earlier version of the tool at the beginning of the pandemic by a professor from Stanford, who's she also has or had a quantum information course, but it was a course in an actual lab. So they work with an actual equipment. And at the beginning of the pandemic, there were lockdowns everywhere, so her lab was closed. And she suddenly had this class that was before experimental, and now she was left only with textbooks. So she started looking for tools that are interactive, and she found our tools and contacted us. And she was using it, and she was sending us those screenshots from Slack, how the students like it. It was a really, really nice feedback that we were getting. But also at the end of the course, she sent us this message saying that even when it becomes possible to teach my class in person again, your website could help me scale to a larger class size than is possible when I require equipment for hands-on demonstrations. And this is something I really like, because I think it shows that we produce this different way of accessing this technology. And because of this, suddenly this opened those new possibilities for her. So suddenly for her, it meant like she still has the class in the lab, but with this interactive tool, she can actually scale the class to much more students than she could put in physically in one class. But also it's, the lab is also used in less serious environments than only universities. And for example, QPlay Learn, they built a game called Treasure Hunt where they use our tool. It's a game about quantum physics, and they use our tool for certain quests there. So, and this is actually something I really like about designing tools in general. It's I think from like design perspective, for me personally, this is very rewarding. If I design a tool that someone then takes and they make something different or like something I wouldn't think of with it. So yeah, this was one of the cases. Oops, sorry. Okay, so let's go to this business category. I'm not even sure if business is the right word here, but I meant the people working in the quantum industry, not the researchers, but all those people around. And even like, forgetting about quantum technologies for a second, like it would, with any technology, right? There are those like sales people, there are business development people that need to in some way sell the technology. Sometimes it's more, of course, not necessarily really selling, but maybe, partnerships. And even if they have this very deep knowledge about the technology, it's still, they need tools to be able to talk about it, to showcase the technology in some very condensed form. And I think with quantum computing, this is very hard. They have very hard job, especially because it's so early. So it's not very easy just to show, yeah, this just works so much better, right? Because we're not there yet. And then and it's also from the other side. So I was in the last few years, like especially having my own company, I was talking with a lot of different stakeholders and also people from, for example, from companies, big companies like banks that are starting all sorts of quantum computing trials and programs. And for example, one person told me, and this was a very technical person, I don't remember if they had physics background, but a person that like they had all the tools to being able to understand the technology. But he told me that I don't have time to learn each technology if I don't know if this is valuable for us. So these are very busy people, and they need a way to understand this technology in a very fast and efficient way. And I remember also during one of those meetings that someone, we started brainstorming together, and they had this idea of just being on a train on the way to work and then accessing the quantum computer from their phone. And I'm not sure if this is, especially on this at this stage, if this is having this mobile app for quantum computers is necessary. But I think it's what they actually meant is this accessibility, right? That this is a technology that is not very accessible. It's not very intuitive. And this is also something that was very, very important when we were working on Pulsar Studio. So one of the use cases we had in mind, and also that's why we tried to keep it very connected to the hardware, is we wanted this to be a tool for a business person, for a business development person to be able to explain the technology, right? So, and I think it's just so much easier to talk about the technology if you can just send an interactive link and someone can interact with it, and you show the most important parts of the technology. And I think this is just so much, it's understandable on a very intuitive level. But also, I think it has value for research. And this was something that, especially with Pulsar Studio, that it's some early version, so I wasn't even entirely sure if this would, for the researchers, if it actually could have value at this stage. We thought more about those like business cases, education, But apparently, we found out that yes, it's even at this stage, it's for some of the researchers, they found out that some things are easier for them to do first in Pulsar Studio, to prototype something fast, to play with it, and before they move to the actual code. One feature that was in particular got a lot of very good feedback was the register window with atoms. And I think this is such a no-brainer, right? Like even here on this image, you can see this is the code. This is the code preview, and these are the atoms. It's obvious that certain things, it's just easier to interact with them on this visual form. And of course, later it's when someone wants to move past this stage, probably other things might be, they would choose the code library. But for some specific things, still, even for the researchers, the no-code interface can be valuable. And when I was user testing the tool, one of the physicists told me, and I like this quote because he told me, I don't even have to think what happens physics-wise. I can just follow what's on the screen. So I thought it's like, oh, we can make the physicist forget about the physics for a second with the interface. But I think, again, like if it's even like just the thing that it's interactive, that, for example, if we have the measurement, we can see exactly what means what happens when. If I just like hover different elements, I can immediately see in all the different places what's happening. And so even just adding this like very basic layer of interactivity, it can make a tool so much more useful. And I added a slide that I call dangerous. Maybe this word is a bit too much, but I just wanted to talk a bit about two things. One is oversimplification. So to build a visual representation, if it's a no-code interface or any other kind of visual representation, we need to, we're building some kind of abstraction. We're using a different kind of language for something that is very complex and is fundamentally not easy to show in a visual way. So I think it's always important to remember not that it isn't some abstraction, but are we really showing what things in a way that is correct and in a way that it's supposed to? Does it really work like this? And the other thing is one-fit-all solution. So this is something that I talked about a bit at the beginning, but I definitely don't think about no-code interfaces as the main solution. I really think the important thing is to produce different kinds of interfaces. So different users, and for different use cases, we have all those different tools to access this technology. So it's not some magical one-fit-all solutions. And I think a lot of criticism regarding no-code interfaces in general, not related to quantum even, but a lot of criticism comes from this, that those interfaces, they're good for certain things, but there are some other things that it's just not the perfect solution. That's okay. This is just supposed to be one of the ways to access the technology. And now I'd like to talk very fast about the process. So again, like I'm not going to talk about like the general design process, just a few things related to the users, the team, and some context that possibly could be also useful during the hackathon. And also these are obviously things that we used in the design process in all those in those interfaces. So first thing is to think what are the current solutions? How are the users working with this problem currently? So if you look at the virtual lab we've built, it's quite obvious where the inspiration came from, right? So this is an actual physical optical table, and where those experiments are being made. And this is a typical illustration from the literature. Obviously, it's also inspired by the way that the optical table looks like. And in our case, we decided that this was the way that worked for us. And by adding a bit of interactivity, where like everything here, all the elements can be changed and drag and dropped, and so we went with this very with the design that was inspired by what the scientists are actually using right now. Another thing that I think is very important is, I called it co-design. So this very collaborative process of design. And I don't think all designers would agree with me, but I think that in general, like, again, not necessarily even related to quantum, but I think good products and good projects are made by teams that consist of people with very different backgrounds, very different expertise. But for something like quantum, I don't think there is any other way around this, because I don't think there are people that would have enough knowledge about quantum physics, quantum computing, product design, development, to really not, like, we need to have those very diverse teams. And this is an image of, I just added here all sorts of different drafts and sketches from a project I'm working on currently with Xanadu. It's a project about quantum data, and all of this is for one specific visualization. And it's something I work with the scientists at Xanadu, and we had so many brainstorming and talks about it, and we try to figure out something, how do we represent one specific thing in a bit more interactive way. And so we're talking about it, like I'm preparing some draft, and then we discover that, oh, actually there are those in those cases that this doesn't work. And it's this process of like talking it again. And I think for the hackathon, I would suggest, I really believe that this works better like this, but I would really suggest to, if when you're building the teams, to look for people with different experience or different perspective of things, because I really think that interesting and innovative things are built this way. And when we have all those like different experience, and together we can find the best way, and it's also just much more interesting. For me, this is definitely really fascinating to be able to work with people who have such different knowledge and such different expertise than mine. And the last thing that I wanted to talk about from the design process, it's to look a bit wider at, I call it learning from other solutions. So, for example, for this specific feature in the Pulsar Studio, so where we have the light pulses here, and their users building a sequence of specific light pulses, and we have this timeline here, and we can have a number of channels. So when we were designing this feature, we thought, like, what are other interfaces that users know that might have a similar, might use similar mechanics? And of course, we don't really have interfaces for arranging sequences of pulses for neutral atom quantum computing, but we have different interfaces that are using, in my opinion, a similar interface. For example, audio editing software, This is from GarageBand, but there are so many interfaces like this, and I think everyone knows it, everyone's seen it. They're very intuitive, probably for most of the users. So we try to learn from them and to see if we can use some of the design they're using. We can learn from the experience of all those, this huge number of interfaces that are available to use it for for designing for the design of this feature. And of course, it's a very different topic, very different use case. But in the end of the day, we have a timeline, we have channels, and we have some kind of waveforms. It's not sound, but it's still a waveform. So I think this is something that it can be very useful in a design process to look at different solutions, not related to what we're doing, but if we forget for a second that it's quantum, maybe someone already tested it and we can learn from this. And that's it. Thank you.
Thank you so much, Klem. I loved hearing, I'm always amazed by your work. You show something like the 2023 image that lights up, and I'm like, wow. And then you show another one, and it's like, oh, wow, really?
Thank you.
You're an incredible designer, and I love how you work in this very diverse and different landscape, right? I personally am an engineer, for instance, also not coming from physics, and I can relate to some of what you have been working through, right? Needing a lot of different perspectives and both visual assets and a little bit of the technical side too. So for those of you coming from maybe math or engineering, we know the math, but not necessarily all of the concepts, and the visual side of things is very helpful. So I have some questions for you, but for everybody in the chat, will have a giveaway after the questions. So make sure to keep asking your questions. If you're active in the chat, your name will be automatically put into the hat for the draw after the questions for Klem. I'm going to ask you some different questions. So you mentioned something about being a synesthete. Tell me more about that. What is it?
Yes. So yes, I mentioned this before the talk. So yes, I see letters and numbers, words in color, but also time. Time is kind of like a Google map. So it's it's not only color, but it's has a spatial form and place. And when I think about, for example, a specific place in time, it's a bit zooming on Google Map to the specific place. I'll be honest, I'm not entirely I don't really understand how people otherwise perceive time. So it was very surprising for me when I discovered that not everyone has this this map of time in their head. So I don't really know how it works for other people. This is the only way I know, but I think it's I'm always thinking if this is in a way, maybe this is one of the reasons why I have this need to find this intuitive visual form for things that aren't necessarily described in such way. Maybe it comes from this very strong personal need that I'm just a person that I need to see everything as having a visual form, including time. So yeah, I don't know, maybe.
Do you think maybe your career influenced how you perceive yourself as a synesthete, and also the other way around? How do both ways work?
I don't really know, I don't think about it so much. I think maybe it's more on some deeper level that, I don't know, maybe being a synesthete, and especially that, the type because there are different types of synesthesia, but this type where I see things like color, that's right, that each word would have a different color. So I think maybe it means that this is, I don't know, more important for me, or somehow more sensitive to this, but I'm not sure. That's probably a question to some scientists researching synesthesia, but it might be.
Oh, that's super cool. I would love to see the world through your eyes. I must say,
Well, I'm trying to build the interfaces,
yeah,
so
actually, you're
you
totally
can.
right. Maybe I'm kind of starting to see it. Um, I am personally terrible at everything design. I think I make great slides, but then I see your slides and I wonder how mine could be so flat. um, Something that we do have really good at QHack is great design too. So here, let me put this up. There's a QHack t-shirt for this year. So all of the designs for this year's QHack are based on the Bauhaus theme, which is like a kind of like a design contemporary movement topic. I don't know how it's called. Um, but you mentioned you actually like a book from before the contemporary era, so like the previous versions of design. Tell me more about this book.
Yeah, so this is I have this book with me. It's a book by Oliver Byrne, and in the middle of 19th century, he designed he produced this. He designed and produced this very like a visual version of the elements of Euclid, where he designed those colorful images representing all the. I think my camera is making it a bit not really visible, but so he built this visual language to describe the math in the elements of Euclid. And I think it's very special because it's mid-century, mid-19th century, so many years before, for example, Bauhaus that you mentioned, and in general, this much more modern way of thinking about design that came in the 20th century. And then like suddenly, like, many years before, there was this guy who just like had this need to make this visual representation of math. And here, of course, he wasn't treated seriously. Only in the recent years, suddenly, people got really interested in this because it's something that we've seen, like 50 years later, 100 years later, but it didn't really exist during his time. And this is maybe not exactly an interface, but in a way, it is, right? It's like he built this different language, a visual language, to describe something that was described only in a mathematical way. So I personally really love it. I think it's a very beautiful example of design. It's Tashem. They're selling this book right now. So like I definitely recommend it. But also a fun fact: my daughter, at certain point, she was like, I don't know, 4 years old, and when I bought this book, she got really obsessed. And she wanted me to read this to her every single evening. So like for a few months, this was our bedtime story, The Elements of Euclid. And, not because she's a math prodigy, but because, this is in a way, and I think this is how I see this being a link to, the no-code interfaces I'm working on, right? So she doesn't understand the math there, but the visual side was appealing to her in a way that she still wanted to hear this. So this is how I think about the interfaces, and this 2023 that I showed, and this fun for the whole family, as someone called it. So I think even if you don't know how to design a quantum algorithm, I think you should be able to use the interface in a very intuitive way.
Oh
Yeah.
yeah. That was so fun to hear, and I must say your kid does sound like a genius. Uh,
No, the genius was the person who designed the book.
oh yeah, them too, definitely. We'll go now with some questions for the chat. It's overflowing with questions, so you have to make sure to keep asking your
Oh.
questions. Okay, so the first question is from Ivana. The question is, like, for the work that you've done, I mean, you mentioned you had a lot of different kind of stakeholders, right? Was there one particular target audience, and were the results what you expected?
For Pulsar Studio or for the second project?
Both, if you want to talk about both or either.
Yeah. So, I mean, the virtual lab, this educational project, this was much more, it was a very open process. And from the beginning, we thought of it like we want this to be free for everyone. And we were, just like doing something, making it public for everyone, getting a lot of feedback and kind of like working with the users. So this was more, it's not really open source currently, but it was the development was a bit like a bit more similar to maybe some sort of open source software that is very this kind of like natural way, and just like like this professor who contacted us, and there were like so many other just enthusiasts or professors or anyone else, and people were like, oh, I would like to show this in this experiment, could you add this element? And in some cases, if we could, we usually would. So this was a very this kind of unstructured process. And of course with Pascal this was different because it was a specific project. With it it was half a year project. We were external developers, and in their case, of course, we had those specific personas that in mind and specific users we were designing for. And I think all the use cases I talked about, so the education, this more like business use, but also the researchers. And with the researchers, I was actually very surprised that even at this stage they found it useful.
Okay. Yeah, definitely. It sometimes you don't specifically target something for a specific audience, but it does end up being useful, and that I think is proof also of great design. Um, M. Van Waveren asks, what kind of algorithms have been implemented with Pulsar Studio?
So there are currently there are some examples here. I think they will probably be adding. I can't really talk about the next stages of development for Pulsar Studio, but there are definitely a number of features that are planned for this for the users to be able to work with on variety different types of algorithms. But yeah, you can for sure you can see for example the examples provided even in this beta version.
Okay, yeah, we can see them here, and well, I guess everybody stay tuned to see what comes next. We have a question from Shul0K. Can you highlight any like a specific insight that you can get more easily from the interface, like Pulsar, instead of looking at equations or algorithms, right? Is there like an example of a specific insight that you can think of?
Yeah, sure. So for example, one thing would be we have this simulation here for up to 12. This is something I just added. This is not, maybe let's just open something that actually makes more sense. One of the examples. So we have a simulation here. It's automatic up to 6 atoms, but it's also up to 12 qubits can be simulated. So for example, the fact that everything is interactive, so we can easily see what is it, right? What it relates to. The same with like everything is explained. So I think this is, I'm not sure if this answers the question, but also like even to learn a bit more about the code for someone who's just starting, I think this can also be a really good way to very intuitive way to learn how to use their code library, for example, that, whatever I can see immediately what's happening, uh, where each element is described in the code. Yeah, and there are, same with, for example, here I can see this qubit on this quantum state window. I can see what it relates to. I don't know if it's visible on the screen, but it's highlighted there. So yeah, I don't know
Yeah.
if this answers the question.
Yeah, definitely. And it was visible on the screen. We were seeing it. Um, there's another question, and I really love this one from Broken Atlas. Do you have any recommended reading or homework to help people on the physics side better communicate with designers?
Oh, this is a good question. Um, I don't know if I have a, a recommended reading. I think this is a very yeah. But like I would say that um, this person is a physicist, yes. So
Yes.
I would say that, and it's something that, like working for a few years in this field, and working also with other people who don't come from don't have physics background, and especially if they also don't have, for example, engineering background. It's extremely intimidating sometimes at the beginning to work with physicists. And so I don't know if it's reading, but I think anything. I think people in general are really curious, and I think a lot of people would love to work in this field, but it's very intimidating because it's like a language we don't know, and no one wants to feel stupid, right? And it feels like it's very easy to feel stupid if you talk to quantum physicists. So maybe not a reading, just remember that like probably people are really interested, but a lot, like most of us, we would be really shy to ask any questions because we don't even have the language to ask this. Yeah, so I don't. So maybe not reading, but yeah, but like it's kind of like the other way around. Yeah, just I think a lot of people, like, we really appreciate if someone uh, mm, can talk about it in a way that's it's easier to understand, right? Like even like the language we use, so we can participate in the conversation about this.
Yeah.
Otherwise, the designers might get scared and run away. So just remember that they're probably just intimidated.
And acknowledging that the language is different and something that
Yeah,
sounds obvious, it's absolutely not obvious. And maybe don't not targeting questions as stupid. That is a good first, right?
yeah, yeah,
Um,
definitely. When I had the company, I remember. So we co-founded the project. We now moved to different project, but for the last few years, um, so I co-founded the company with quantum physicists, and I remember one specific situation. There was a person that was supposed to help us, I think, build a pitch deck or something, like very business related, and she specifically asked to meet only with me, and she told me, like, I want to meet with you because I know that if it will be you and the quantum physicist, I will feel a bit intimidated. So I think it's a very common feeling, and I think it's terrible, of course, but that's something very, yeah, very, very natural. So like yeah, just remember that probably people are really interested in this field, but it can feel a bit scary, and yeah.
yeah. And I mean, you're talking from a designer's point of view, but there are people here coming from all kinds of backgrounds, right? And it happens for everyone. I think even people coming from scientific backgrounds, you don't have all of the context. I've seen people come from engineering or math. They don't necessarily have the math background. And sometimes we're afraid of asking. but I think we should keep pushing ourselves and remembering that our diverse backgrounds make us more valuable, and we can add stuff to this field. So what everything we've shown us today, your design background actually is very special and something to be proud of. And asking questions is it's very important. So a little bit of bravery and understanding from the other side are super important.
Definitely. Exactly. Yeah.
Okay, we have one last question for you from the audience. So everybody, after these questions, we're gonna do a giveaway. So the last question is from N. Hawkins, Seattle. Klem, how did you find quantum, or did it find you?
Great question. Yeah, this was a coincidence. I'm not going to lie. So I just, saw someone writing about this project in Singapore, and I thought like, oh, this is going to be really funny on my CV. To have this like for a few months. Suddenly, I work at the Center for Quantum Technologies, and I thought, oh, it'll be cool to go to Singapore for a few months, and so it was like definitely no plan of. I just thought like it's so weird that it must be interesting. And then I started working in this field, and I thought, oh my god, this is like, first of all, it's so fascinating. I mean, like, and this is something I definitely feel all the time. It's just like so interesting for me, and I really really love it. But I also thought that there is a certain opportunity here, and there is something that I can add to the field with my particular experience. So it was definitely just a coincidence. There was no plan there. Yeah, but I'm happy it happened.
Oh yeah.
But me staying, it wasn't a coincidence. Let's say like this. That was a very conscious decision, and something I'm extremely happy about.
I'm extremely happy about that too. Honestly, Klem, thank you so much for the work you've done in the field. It was great to have you today. For everybody in the chat, stay tuned. Don't leave just yet, but I will say goodbye to Klem. Thank you so much.
Thank you so much, and good luck everyone at the hackathon.
Thank you. Thank you,
Bye.
Klem.